Alright guys, so we're going to go ahead and get started with Q4 week 3. Make sure that your name is here. So, Matt. Okay. We're going to go through this. Alright, remember, don't start with the studies, start with the questions. Always, 100%, always. At least for the science test. So, if glacier model used in study 1, so study 1 is where I'm going to look, is typical of all calving glaciers, or calving, I don't actually know what word we're supposed to say. The scientists would draw which of the following conclusions should clue us into, that's an EMI question, that's an EMI key phrase, about the relationship between glacier length and calving rate. So, study 1, relationship between glacier length and calving rate. This is also a trend question. So if you said this would be IOD, you would be not entirely wrong. So, as time increases, okay, let's see where these start. So it's as calving rate increases, as glacier length, so we could look at both. So as glacier length, this is kind of a plateau, and then there's a sharp decrease. And when that sharp decrease happens, calving rate has a sharp increase. So, let's see. So, as calving rate decreases, this always increases. We can say no, because glacier length isn't always increasing, especially not here, and that's decreasing. So, we need to look at the sharp increase one. So we can cross off A and B because it says always, and we know that's not true. And because we crossed off A, we can cross off B because of our strategy that these are almost the same. These are also almost the same, so let's see which one is right. So a sharp increase in calving rate results in a sharp decrease in glacier length. So this sharp increase results in a sharp decrease here. So I'm going to say yeah. They definitely don't both increase. It's an inverse relationship. So the answer is C, with D being the distractor. So when one goes up, the other goes down. And remember that this relationship is called an inverse. Okay, question 2. I've abandoned the yellow for this week, so you should be able to see it. The meteorologist in study 3. So where am I going to look to find the answer? Probably in study 3. Hypothesized that the faster the calving rate, the faster the sea level at a calving glacier's terminus would rise. If this hypothesis is correct, which of the following glaciers resulted in the fastest rise during sea level? Okay, the faster the calving rate, so let's see what's the highest. That's an increase. The faster the sea level at, we need to look at years 6 through 10. Whoops-a-doodle. So, years 6 through 10. And then we need to look here. So, study 3 is about Glacier C and Glacier D. So we're probably only going to be looking at Glacier C and Glacier D. And then years 6 through 10. This one has a high calving rate. The faster the sea level would rise. Which of the following has the fastest rise in sea level during years 6 through 10? Okay. So let's really take this question apart because there's a lot of pieces going on here that can throw you off. So we're mapping out stuff. So meteorologists, it was in Glacier C and Glacier D during the same year 10-year period. It was hypothesized that the high temperatures were responsible for relatively rapid calving rates for C and D. Okay. So this is what they guessed, right? So you don't actually need to look at study 3 because you just need to read here. But now we need to figure out which one has the high levels here. So C and D is what they studied, but this isn't actually an experiment. That's just what they guessed would happen. So that is a question that's meant to throw you off. Here, let's actually look at the whole table. So we can't quite cross this out yet. So We do know that we just need to be looking at this half of the table because it's years 6 through 10. So the faster the rate, the faster the sea level at a calving glacier's terminus would rise. If this hypothesis is correct, which of the following resulted in the fastest rise in sea level? So we go to years 6 through 10. This is IOD, by the way, because we're pulling it out of the graph. Go to years 6 through 10. Let's find the highest calving rate still. Okay, so it's C is the highest calving rate, and we know that higher this, then higher that, so that would be H. Okay, so there were a lot of pieces in that question that would throw you off. The distractor would probably be D because it has the highest rate for years 1 through 5. All right, so that was a loaded question to pull it out of the table. All right, question 3. Based on the results of study 2, a glacier traveling at, I'm just not even going to say this word anymore because I don't know how to say it correctly. I don't know if it's calving or calving. I'm not familiar with glacier studies. So based on the results of study 2, a calving glacier traveled at a velocity of 80 meters per year would most likely have a calving rate. Oh, I said it again. Here I am. Okay, this is IOD because it said most likely, and then it's asking you for a number. That's an interpolate, extrapolate question. It's 404. So we're going to go to study 2, which is here. A glacier traveling at a velocity of 80 meters per year would most likely. So we need to figure these out. So right here, let's see. We would stack up this table. Let's order it. So 51, 72, 98, 160. That's my velocity. And then we'll reorder this. 52, 72, 106, 189. So where does 80 fall in between there? 80 is right here. So that means my rate is going to be between 72 and 106. Right? So the distractors here would probably be this one, because you would, let's see, this is 45, 53, 63, and then 256. So that's 47, 54, 64, 312. Anything between these values is probably going to, that's like the reason that you don't look for years 6 through 10. You're not going to look between 64 and 312. That's just too broad of a range, so you won't look there. So that actually won't be a distractor. So then it was, it's going to be either one of the ones on the either side of this. So did you accidentally say 80 belongs in here or 80 belongs in there? And this was interpolating, which used to be like one of your highest standards on the interim, but has since, we've taken a downturn on interpolating, so we'll need to work on that one. All right, question 4. Which of the following statements best describes the behavior of the glaciers observed during study 2? All the glaciers observed traveled faster during the first 5 years than the last 5 years. Oh, and again, study 2. So we're back at it for this one. There's a popular table for this. All right, this is still going to be an IOD question because it's asking you to pull out a description of the data. So all of the glaciers observed traveled faster during the first 5 years than during the last 5 years. So are all of these numbers higher than these numbers? And the answer to that is no, because of that. So we can cross off F. All right. All of the glaciers observed traveled faster during the last 5 years than during the first 5 years. We can cross that off because 45 is less than these. So no. The calving rate is always less than the average velocity for all the glaciers observed. 312 is bigger than 256. 106 is bigger than 98. So I'm going to go ahead and cross that off. You can prove that wrong. All right, the calving rate is always greater than or equal to the average velocity for all the glaciers. Let's see. Greater than, greater than, greater than, greater than, equal, greater, greater, greater. So yes, the answer is J. So you just map out in the table. Okay. Question 5. Which of the following graphs best represents the relationship between calving rate and average velocity in study 2 for years 6 through 10? So let's see. Is there a trend here? So calving rate is on my x-axis. So let's see. It goes, let's assume, 64. Well, we'll just map it. So 47, 54, 64, 312, 45, 53, 63, 256. So as we map this out, there we go. So at 47, that's like 50, what was it? Yeah. 53, 54, they were about equal. 63, 64, and then it was 312 and 256-ish. But that's putting, no, that is putting the right numbers. Okay, 47, it did not dip to 54. So the answer to this one is B. This one, I don't really have any tricks to this. So 1, this is IOD, but you just have to map it out. But if you do line them up in the right order, so for that one, line in order. And then draw how that would be. So that, like, this is an increase in, so it's increasing and then bam. That's just all it's doing there. So you would just have to trace that graph. All right, and the last one. If the hypothesis made by the meteorologist in study 3 is correct, the glacier module in study 1 most likely experienced unusually high temperatures during what time? So this is an IOD question because it's asking you to combine two things. So we're going to flip back to study 3. They say unusually high average temperatures during the same time. It was hypothesized that the high temperatures were responsible for relatively rapid variations in velocity and calving rates. So that would be in glaciers C and D. Like, why did these change so much? Why did it go from 256 to this? So on that graph, why did we have such a change? So like we're chugging along, it's fine, and then there's an instant drop. So why did we have that? So that means that at this time, if you look at the graph on the x-axis, it is between, or it's about 1,500 years. So right there. So why the sudden change? And that's that one for today.